Question number 9 on page 276 says a point on an industrial flywheel experiences motion described by the function h, and h is in height in meters and t is in time in minutes. So part A asks, what's the maximum height of the point? So looking at the graph of this, we can see very easily, but basically what we're going to do is looking at the function, we can see that the vertical shift is 15, I've highlighted in green, and the amplitude is 13. So to get a maximum, what we do is start at the middle and add the amplitude. And we can see that here, starting at 15, adding the amplitude, we're going to end up with an amplitude of 13, and we end up with a maximum of 28. The same can be said for part B, where we go down 13 and we end up at a height of 2. So it's going to answer, so height of 28, and the minimum is 2. And it says, how many minutes is the maximum height reached? So looking at this, the period of this function is given by 0.7. So that represents the period, and we can say that either the maximum happens at 0 or it happens after one period, which is 0.7. Okay, so 0.7 right there represents where the maximum occurs. Okay, so I'm going to put in here either 0 minutes, or we could also say 0.7 minutes. And for the minimum, we know that's going to be halfway through the period, so that will be at 0.35 minutes is where the first minimum will be reached. So t equals 0.35 minutes. So part E says, for how long within one cycle is a point less than 6 meters above the ground? Well, taking a look at E, 6 meters I've marked in yellow, and we want to know the time it's going to reach 6 meters above the ground. So it's going to be at approximately, we could point it here, trace that down, from here to here. And what we want to do is we want to find these two times, which we're going to call T1 and T2. And to do that, we need to set up an equation for this. So for part E, we're going to set up an equation, and we're going to make the height equal to 6. So we're going to say 6 is equal to 13 cosine of 2 pi over 0.7 t plus 15. So solving this, we're going to undo the plus 15 first. So we're going to end up with negative 9. We're going to divide both sides by 13. And then we're going to undo the cosine with an arc cos, or inverse cosine function. And then finally solving for t. So this is going to represent t1. And this happens to be the first angle. But t1, we're going to end up solving this. We're going to get a decimal value. Then we still need to solve for the t by multiplying that by 0.7 and dividing by 2 pi. That's going to be equal to the t1.